low. How do we make sure we hit this order of magnitude lower cost we want? Well, there's a couple key things here. We're relying on these low-cost commodity wide-gig chips to be able to put in these client nodes and these distribution nodes. These are really cheap, they're commodity, they're showing up in your homes and your phones and your other devices. The other thing that we take advantage of is that we use unlicensed spectrum at the 60 gigahertz range. Now there's lots of spectrum available here, so we have lots of capacity. The other thing that's great, it's unlicensed, so we don't have cost to procure this spectrum. And finally, 60 gigahertz in that industry has always been something that was, frankly, a bit frowned upon because it gets really easily absorbed by water and oxygen. So it doesn't have a very good range. But we take advantage of the fact that it doesn't have a very good range to minimize the interference as we broadcast through the city and to also keep the capacity high. Now we're also taking advantage of our extensive experience in our massive data centers and our scale-out technology. Because we built a cloud computing controller here that will help route around obstructions and interferences. We've made this whole network IPv6 only as well, and that the system will recover when there are interferences or outages, and it'll be a very high reliable system. Now we're doing a test at our Menlo Park campus down the street, and we've been able to achieve multi-gigabit per second link-to-link transmission ratios. And this is just awesome because we're going to be able to bring this high-capacity urban Wi-Fi connectivity solution to bring more people online and to do it more affordably. The other thing I'm really excited about is that we're announcing a trial with the city of San Jose. We're actually going live with Terragraph later this year in downtown San Jose. So that's really exciting that we'll be able to see this thing in the wild in downtown San Jose and be able to use it and test it. And from there we'll be expanding out to more cities around the world. Now, it's not our aim, it's not our goal to keep all this stuff to ourselves. We're developing this technology in the open. We want it to be interoperable. And we're going to continue to work on Terragraph and take the components that we're working on in Connectivity Lab and contribute them to the Telecom Infra project. We founded the Telecom Infra project a couple of months ago with a couple other industry-leading companies, and there's over 300 partners now that have joined this community to expand and to bring more affordable and faster connectivity solutions to help connect the unconnected. All right, so to wrap up here, I think it's important to kind of highlight a couple things. One is our approach here is really comprehensive. From bringing Terragraph in the city to be able to bring more people online and to bring connectivity to them at a cheaper rate, to things like Project Aries that will extend out connectivity to tens of kilometers out to these suburban environments, to our development in UAVs and Aquila specifically, and satellites to bring connectivity to people who are hundreds of kilometers outside of a city. Now, one important note here is that it's not our aim here to build and deploy and to run these networks by ourselves. We're just trying to advance the state of the art. We really want to show the industry that it is possible to build technologies that are 10x faster or 10x cheaper or both, and that we want to help accelerate how people get connected to the internet. Now, we have a long journey ahead. There's still many, many hard challenges in front of us, but I'm excited that we've taken the first couple of steps. Thank you. And next up is Joaquin, who heads our Applied Machine Learning Lab team.
Good morning, everybody. How are you guys doing today? Good. All right. Yesterday, we told you that we are working on AI in order to help people connect and share in more natural and intuitive ways, okay? I like to think about this as we are giving you communication superpowers through AI. And the way we're doing this is we've built this AI backbone that powers pretty much every aspect of the Facebook experience. Over 25% of engineers across the company use it to run 50 times more experiments today than a year ago. And this is a big deal because it means that research is hitting production faster than ever. It's powered by a massive 40 petabyte, oh, my clicker doesn't seem to be working. Oh, there we go, sorry. All right, sorry, could we go back to the previous slide? I missed the click. All right, thank you. All right, I was telling you that it's powered by a 40 petaflop GPU cluster, okay? And teams are using it to train massive models with billions of parameters on gigantic training sets with trillions of data samples. What I'm gonna do now is, I'm gonna take you through a couple of examples of how this works, okay? When you load your newsfeed, a personalized AI that learns your preferences analyzes not only every news story available to you, but also all significant old memories. And the cool thing is, it's able to generate pretty amazing blasts from the past, like this one I'm going to tell you about, okay? So this here is a post I saw earlier this year of a ski trip 2 years ago. This was the first absolutely amazing ski trip my family and I did together. And the reason it was amazing is that for the first time ever, we were able to ski down the slopes for an entire day together as a pack, even hitting some black diamonds together. So this is a kind of memory that I'd simply never forget. So I went ahead and I shared this post, which is really cool for my dad because he lives in Spain and he really relies on Facebook to keep up with what my family and I do, or rather I should say, to keep up with his grandchildren. That's what he cares about. The thing is, I posted in English, and my dad does not speak English. Like my dad, most people in our community actually do not speak each other's languages. So what we've done is, we've built this machine translation system that is helping 800 million people every single month see translated posts in their newsfeed. Let's take a look at how this would feel for my dad, okay? So he'd see translation and see the translation, which is awesome. All right, the language on Facebook is human to human. It's alive, people use slang, there's regional differences, and some lazy people like me don't even finish their words, right? So you can't use an off-the-shelf translation system because they tend to be trained on things like appliance manuals or government records. So what we did is, we built our own from scratch, and in this way, we are working on eliminating language communication barriers, okay? But there are other communication barriers. There are 40 million blind people in our community and about 250 million severely visually impaired. One key component of the AI backbone is a computer vision system that classifies every single image uploaded to Facebook every day into multiple categories. It'll be able to say whether the Eiffel Tower is on this photo or whether there's a cat. And we've used this to build a much more immersive experience for the blind that I'm going to show you right now.
Facebook, search. What's on your mind? Vincent Chun, February 2nd at 3:16 p.m. Amazing ski day at North Star with Joaquin and his family. Photo, image may contain snow, people, outdoors. 11 eyes running and 12 others reacted.
All right, so the system was able to detect that there were snow, people, and outdoors in this image, which is great. Building this image classifier is again something we really had to do from scratch because the scale and diversity of images uploaded to Facebook every day by far exceeds anything out there. What else could you do if you had such an image classifier? Let's talk about social image search. Imagine that in a few years from now, my daughter is getting married and I want to go ahead and find that memorable family ski picture, okay? I could go ahead and search my photos, but I'm very disorganized. It's not in my photos, okay? It's somewhere in some photos some friend of mine took, but in a few years I have forgotten who took it. So I could go ahead, using the fact that we can categorize images and type in snow, and then I'd get results. I'd see photos taken by my friends that have been classified as containing snow. Potentially this could be a huge list, but I got lucky and the image is right there. So this is pretty cool, but we can do a lot better than that. We're doing research on cracking the image open and understanding it at the individual pixel level.